Now let's look at the inverse tangent function. Can the tangent function have an inverse? The answer again is yes, but only if the function is 1 to 1. So is this function 1 to 1? Although we can see that it does pass a vertical line test, right? I draw a vertical line and the graph only goes through one spot. If I reverse that and do a horizontal line test, I see that I cross in multiple spots. So I need to restrict this picture or this graph or this function. I need to restrict its domain. Before I do that, let's take a look at this example, making sure that we understand how the inputs and the outputs reverse. If the tangent of pi over 4 is equal to 1, then what we know is that the tangent inverse of 1 is equal to pi over 4. And so what was an input becomes an output, and what was an output becomes an input. And here's our formal definition. The inverse tangent function, y equals tangent inverse of x, means that x is equal to tangent of y. The inverse tangent function is sometimes called the arctangent function, and it's notated by arctan of x. So y equals tangent inverse of x has a domain of negative infinity to positive infinity, and has a range from negative pi over 2 to pi over 2. And you might recognize this as being similar to the sine function. So why did they pick that restriction? Well, like we saw before, by restricting it from negative pi over 2 to pi over 2, we include positive values and we include negative values. Now notice for the tangent function that we can't include the actual values of pi over 2 and negative pi over 2 because those are vertical asymptotes of the tangent function. That was not the case with the sine curve. So here in our graph in blue is the tangent function over its restricted domain. We have the line y equals x, and if we fold on that line y equals x, we will see the inverse tangent function graphed in red. Example 4. Use a calculator to find tangent of 13 pi over 7 rounded to 2 decimal places. So, am I in radians or am I in degrees? Well, we're using a tangent function. This is my angle. There are no degree markers, so we must be still in radians. So if I put into my calculator the tangent of 13 pi over 7, my output is going to be approximately, what my calculator says is negative 0.48. Make sure you get the same thing. So based off of this answer, if I reverse my inputs and my outputs, I should get an answer of 13 pi over 7. Confirm that with your calculator. So again, let's use the unit circle. It says to evaluate tangent inverse of root 3. So let's think about this for a second. We want to find out what angle produces a tangent of root 3. So square root of 3 looks familiar. I know that that's not going to be an angle that's in fourths. It must be either in sixths or in thirds. What I also know is that my angle has to be between pi over 2 and negative pi over 2. The other thing that I think I know is that because I'm dealing with a positive square root of 3, the only place I'm going to see a tangent that's positive is going to be in quadrant 1. So I believe my answer is there. The question now is it pi over 6 or is it pi over 3? Well, if you recall that tangent comes from sine over cosine, let's see what we've got here. If I use pi over 6, then that would be sine over cosine, which is 1/2 times 2 over root 3. The 2's cancel out. I'm left with 1 over root 3, and when I rationalize the denominator, I get root 3 over 3. So it looks like pi over 6 is not the answer, and pi over 3 is the answer. And then the last one, evaluate tangent inverse of -1. Where does the tangent equal -1? In other words, again, what angle is going to be produced? Well, in order for it to be -1, we know that the sine and the cosine have to be the same thing. And because it's negative, we know that the sine and the cosine not only are the same thing, but they're actually opposites. One is a plus and one is a minus. And I believe that that would be happening here at 315 degrees, or 7 pi over 4. However, for me to get to 7 pi over 4, I would have to go through my wall. So instead of writing it as 7 pi over 4, I'm going to write it as -pi over 4.